And I wanted to talk to you about choreography with Spring Cloud, practical choreography, and what I understand by that. So I work as a tech lead for Scott Logic. That means I had a chance to work on a couple microservices projects already, and plenty of my colleagues work on different microservices projects. So that comes from some of the discussions I had with my colleagues and kind of observations that I think I made. So one of the main challenges, I think, when companies transition to microservices or when startups take on microservices is solving these communication problems. You know, it's important that that you have it solved because, you know, suddenly you have loads of communication. In monolith, everything was inside, and here you have different services talking to each other. So you want it to be easy to work with because you'll end up working with it a lot. We don't usually want to choose a risky or unknown technology because obviously that's a key element of your system. And we want that communication to be reliable. And it would be nice and if you could easily add or remove the services, as you know, that's the core of why we use microservices, so that these things are easy. So I think the go-to pattern is orchestration. That's what a lot of people, a lot of companies naturally gravitate to. Orchestration is having a service decide itself. You know, I will call service A, service B, I'll get the response, kind of like the conductor in the orchestra, you know, playing one single person or service directing. So yeah, orchestration is great. You know, if it wasn't great, it wouldn't be popular. Making REST calls between services, yeah, that's easy. The flow of execution is implicit, so we understand what is going to happen in the system. Most developers know how to get started because even if you worked on monoliths and any technology, web technology, you probably know about making REST calls. It's not necessarily REST calls with orchestration, but let's talk about that for now. And there is usually not much extra middleware necessary, or I think that's what a lot of people jumping into that think at first, that there is no extra middleware necessary. But you need to have load balancing, you need to have service discovery, you probably want some kind of service proxy. You know, you introduce potential for tight coupling here if you're not careful, because you have two services and suddenly maybe they're super chatty between each other because they know that of each other existence, and you create this tight couple. You know, if that kind of continues, you may have this God service anti-pattern. So you started with microservices, but you have a service with 50,000 lines and a few tiny services just symbolically. So that's not really I mean, this is microservices, but microservices that need some work on to really benefit from the great things that the previous speakers kind of were talking about here. And you know, if you're all tight coupled, it may be quite difficult to add new services to that party. So choreography, that's what I will focus on. That's, you know, kind of like in a ballet or in some kind of dance performers, that you don't really have conductor. You know, you have the choreography, but every dancer or service kind of know its place and know what to do. And that sounds great. But I think a lot of companies are a bit scared of it at first. So I will first tell you why I think choreography is great. It's basically the key, what choreography is the event-driven reactive microservices. You don't have a service telling other services what to do so much. You have services announcing an event happening, and you have other microservices reacting accordingly. So you usually use message channels for that, kind of message brokers. Services will have to know what to do when different event happens. And the loose coupling is baked in the core concept, because if one service doesn't know about the other service existence, it's very hard for a tight coupling to develop because they just don't know that they even exist. So you can still get problems in coupling there, but not as easily. It's very easy to add new services because there is no implicit calling of a service. If you get your domain right, domain model, then it could be easy to add these new services. It's easy to scale. You know, with orchestration, you need load balancing and all that. Here, often you just need to make sure that the message is consumed by a single service, and you get that kind of implicit scaling. And it's worth looking at because world's largest microservices deployments use this pattern. And we know that because they write and talk about it. Like Netflix was mentioned countless times, and they make good use of a lot of this stuff. So why so often we see orchestration, and why choreography still sometimes doesn't exist in some microservices deployments? That's basically not industry-wide research. That's my experience working for software consultancy, that most of our clients go to the orchestration. I think it's, I have here five points. First, that I will discuss. First is it's more difficult to reason about the system in choreography because you don't have these implicit flows. It's not so obvious maybe what will be happening. There is, I think, a bit less experience among developers with this system. As I said, making REST calls, making orchestration, that's kind of natural for most developers. And there are three other kind of potential problems that it seems difficult to get started. It seems difficult to just bring orchestration into your system. Choreography into your system. It seems difficult to deal with exceptions, errors. You know, if you have this implicit flow, something breaks, you know where you stand, you know at which point it happened. In choreography, not so much. You don't have implicit knowledge of the flow, so it's harder to handle that. And I think some companies are a bit afraid that it may be more difficult to just know what's happening in the system in general. We've seen the previous talks how monitoring is key, and it's important for so many of these companies. So let's start talking about, is it really more difficult to reason about? Well, I want to challenge it slightly. So if you look at the actual single microservice, in orchestration you have one service calling another, getting response, calling another. You have this whole flow. So your service needs to be aware of the larger picture when you're looking from the perspective of a single service. In choreography, you mostly, for your interactions, you mostly care about publishing your event and maybe listening to some other events, but you don't have to really be aware of a specific instances of services. So yes, while the whole system maybe becomes more complex, the single microservice, I think, actually becomes easier in isolation. So there is a value to readable source code and to kind of nice composable microservices. So I think that's 50% true. There is less experience among the developers. I think that's true. At least that seems to be true by me talking to different companies about what they're used to doing and what's the thing that is natural to them. So I would like to kind of suggest what we can, if we want to be the champions of choreography messaging in our companies, how do we get started? I kind of like this learn, play, learn, teach. So first you can learn about solution of choice. I'm here talking about Spring Cloud. If that's something interests you, you can kind of learn about Spring Cloud. Then you can play with it a bit, maybe build a system in your kind of spare time just to see if that's something that you find easy to work with. And then learn some more, because the first learning, you kind of don't really know what you're doing. But the second phase of learning, you already played with the solution, so you kind of have natural questions coming up in your mind, and suddenly that boring book became so much more interesting, or that boring Pluralsight course that after 3 hours you're just falling asleep. Suddenly you're like, oh wow, I want to know more about that. And then teach others. So, can be a brown bag in your company, it could be a chat with other developers, writing blog posts, anything really. But I think that works reliably. And it seems difficult to get started. Yes, maybe it seems, that's true, but I want to challenge that I don't think it is actually difficult to get started if you know what you're doing. So my tips, if you're starting out with this, is to choose an opinionated framework. Choose something that kind of has its own opinions, how you should deal with it. That's why I really like Spring Cloud, because it's very opinionated. It's made by very good developers from Pivotal and larger open source community. So, the kind of decisions they made, they're made by people who work day in, day out with microservices. So if you don't know where to get started, do what they do. And once you get familiar, you can freestyle a bit. So choose something popular. I would say, don't go for something that was started last week. In JavaScript, there is new framework every month, but in microservices, maybe a bit more risky to kind of go that brave into that world. And play with the framework. Of course, make sure that you're not advocating something you end up hating. And once again, I could not recommend Spring Cloud enough. I think it's great JVM tech. So I'll base rest of that talk around assuming you choose that. Of course, you could choose something else. So choose your plan of attack. It's important to know where to start. If you start choreographing everything, you may fail and get discouraged. So I would say choose something that makes sense and that naturally fits into choreography. You might have heard about 12-factor app by Heroku. It's an idea of doing like a very good microservices or like service deployment in a cloud. Point 11 is logs. Treat logs as event streams. And I think that's really nice place to start because we already log. We know of the importance of logs. And logs or domain events, they really fit well in this kind of messaging pattern. And if you already have your logs there being the event stream, you have kind of like built the baseline of which you can start. If you want to send some emailing alerts out of some specific event in these logs, you can do that. If you want to suddenly do some monitoring, anything really, emails monitoring, you can hook that to the log stream, and that can be your baseline for introducing more and more of this good stuff. In general, I would say look for long-running business processes as well. I used to work in finance product company. We had processes that would take weeks, because there would be like legal resolution of things. And if you try to do it with, let's say, some bad jobs on databases, it just becomes painful, and it's not really, as developers, we like when things move fast and in a orderly fashion that we can do it. We don't really usually enjoy massive batch jobs that fail halfway through for unknown reasons. So I think any sort of long-running business processes, if you can identify them in your company, there could be your kind of starting points for introducing that. So choose the right tools. For the, I think, third time, I'll be saying Spring Cloud, but Spring Cloud Stream is the specific project that is part of the larger Spring Cloud that gives you, I think, great abstraction on top of the choreography and messaging kind of ideas that won't bind you too closely to the broker and kind of shelter you from a lot of the nastiness of manually configuring message brokers. So RabbitMQ, you could use Kafka. Kafka is amazing, actually. But Kafka, I think, tends to be more difficult to work with if you're just starting out. But again, personal choice. If you like Kafka, I would say go with Kafka. But with Rabbit, you don't need to have Zookeeper. You have kind of built-in dashboards, so you get a lot of freebies. If you're new to that world, I think you'll find it a bit easier. And have a look at this Spring Cloud Stream application. That's actually the whole source code. It's a Spring Boot application that you have the annotation, enable binding, and you're listening to the input to process the message. And you're printing out the message. So it doesn't do much kind of interesting stuff, but I think the key is that the part of the code that deals with the messaging, with the choreography, is actually these 4 lines, which, I think that's stunningly simple. This will actually even set up the stream for you. Stream is the abstraction you kind of have. That will do it automatically on the RabbitMQ as long as you have it connected. So you don't have to be bogged down into configuring your broker. You can kind of get started quite quickly. And speaking about configuring your broker, that boils down to host port, username, password, and input destination. So that's kind of the message stream you want to be reading. I'm saying stream because that's the Spring Cloud Stream abstraction. If you're using Rabbit or Kafka, that would be either become like Exchange or something else on Kafka. And you set which groups your microservice belongs to, so that you can have more microservices in that group, and you have guaranteed that only one of these services will process the message. So that's this kind of implicit scaling. You don't have to do anything, and you have some scaling already. So second point, second from last, that there's not much more longer here, so you'll be able to go and enjoy a drink. So it seems difficult to deal with exception. Yes, I think it is at first, but so you need to choose something that works. And if you know what works, for example, in RabbitMQ, you could use the dead letter queues. So any sort of exception you get, you put it on a dead letter queue. How do you switch it on? It's a single property. You start your microservice. Because Spring Cloud Stream is amazing, it will start talking to your RabbitMQ, configure it all up for you, and next time you get an exception on consuming of a message, for example, it will automatically take off this message, put it on a dead letter queue, and then you can either look at them or you can process them with something else. So that's I would say the first part of dealing with exception, because okay, we dealt with it, it's not lost, there is some flow of handling it. Then there is the part about actually understanding what happened and kind of looking into the logs. So let's look at this in a moment. So yeah, it's difficult to know what is happening with the system. I think that's big kind of scary thing for a lot of our clients that tend up to be bigger financial institutions, that they really want to know what's happening, and they really like these implicit orchestrations. So you could have, this is not choreography, that's orchestration. You could have some requests to services, requests, responses, going back and forth across number of different microservices. So what you want in all of that is to know that this single request that originated here and log from here, that they're all related, that they're part of kind of one business transaction. There is a Spring Cloud project called Spring Cloud Sleuth that adds this request tracing, and all you do is put that dependency in your Spring Boot, and suddenly you have that tracing enabled. You can configure it to your liking, of course, but you have the basic enabled. And then you will have like trace ID and span ID that goes across all of that. Great. So now if you look manually in your logs, you could look at some IDs and you could correlate it all, and you have a story from it. So what do you do with these logs? Because you're not going to manually be looking into logs. That's in microservices, 6 different copies like rightmove had here, or 10 different microservices. That's crazy. You'll spend your whole day looking at logs. Elasticsearch, logs-kibana, get your logs somewhere that you can just put the correlation ID and you get them all displayed. That's great, makes your life so much easier because you can suddenly see what happened across all of that. But still, if you really want to understand what's happening in your system, I think you're still not satisfied if you're using messaging, because, okay, I have all these logs, but what actually happened? There are all these queues here, there are all these, it's not the full story. So welcome project Zipkin, which is a very nice project that takes these Spring Cloud Sleuth logs. Again, you put few properties here and there, pretty trivial. And suddenly you can visualize. You could say, my request that originated here was consumed by some publishing service. From the message channel, this is quite small, but so I'm talking from this message channel, then it was retried by the dead letter queue processor, put again onto this, it failed on the consumer, was retried by the dead letter queue processor, consumer again, and you can see trace the request till the end with the timelines of it happening. And the power to do it on any request in your choreography is quite amazing, because suddenly you could really start to understand what's happening, and the message, you don't lose your context by going asynchronous into your message queue. Because I think that's the fear of a lot of businesses, that the moment you go on a message queue, it's really hard to keep track of what's happening. So with Zipkin, that you configure like that, again, what I want to kind of draw your attention to is simplicity of that because you chose opinionated framework like Spring Cloud, everything is pretty simple. And yeah, if you want to do something fancy, you can, but you have out-of-the-box simplicity working solution that you can then, tweak to your liking, and if you need anything special, you can probably get it because it's very customizable. You can even click at one of these exceptions there, and you get the exception printed that was there. So you really get a lot out of very, very little effort. You get a lot for it.